Welcome to the Stormsurf video surf forecast for the week starting Sunday, August 12th. Looking at significant wave heights for the South Pacific Ocean, we see not a whole lot going on. This has been the pattern, it seems like, for almost a week now. Yeah, there have been a couple of gales that have traversed the South Pacific, but nothing too impressive. And currently there is a little bit of low pressure here, presumably, generating, what's that, about 24-foot seas, but all aimed off to the east, southward displaced, and it appears that large high pressure, at least in the upper atmosphere, is basically pushing the storm, as the storm track, into Antarctic ice, and of no use to us in terms of swell generation. Yes, some other low pressure here is off South America, but not generating any seas of interest. All the focus, like it has been much of this year, is focused on the Indian Ocean and South Atlantic. So the Pacific right now is pretty calm. So let's take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough that is a push in the jet, specifically the southern branch of the jet to the north. Yeah, there is a little bit of a trough here in the far southeast Pacific, but the relative to our forecast area, Southern California and Hawaii, and Northern California, of course, this trough, for the most part, is east of the swell window for even Southern California, with the core of it, the peak of the trough, that is right here, up about 110, 100 west, out of our swell window. Anyway, but when you do get a trough, what troughs do is help create a clockwise circulation in the upper atmosphere. And in the southern hemisphere, clockwise circulation is the sign of low pressure. And if low pressure is deep enough and strong enough, it creates good winds, and those winds help generate seas. And seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, creates surf. Anyway, looking at what's really going on here, we see the jet stream. The ice line's right around maybe 63 south or so, like somewhere along this line here. So you see, if the jet stream is pushing over Antarctic ice, which is not depicted on this image, then really there's no hope for storm production. In this case, we have a zonal flow. That is the jet running west to east, flat, with no troughs from south of the Tasman Sea the whole way across the South Pacific, except in the extreme southeast Pacific, and that's where this trough we were talking about is. So right here, basically, this, when you get this sort of split pattern like this, that's symptomatic of high pressure in the upper atmosphere, and that's not good for producing surf at all. Anyway, so let's roll out. We see the pattern basically holds. Now here comes maybe another ridge building. No, not quite. Yes, somewhat. As we get into, now we're into Wednesday night. I mean, just sort of the steady state pattern has been the rule, with this sort of weak troughing thing going on in the southeast Pacific, extreme southeast. Look, it's the jets coming off of Antarctica, deep off of Antarctica, so the whole southwest Pacific is shut down right now. Not good, and that just continues. Now as we get into Sunday, we're almost a week out now, late Saturday night. Another little trough tries to develop, far southeast Pacific, but even outside the Southern California swell window. And here we are at 180 hours, and just nothing that looks supportive of gale development in the southern hemi. So next off, let's take a look down at the surface level pressure and surface level winds. And as expected, we had this split jet stream flow. Sure enough, there's high pressure. Not strong, 1020 millibar, but whatever fetch there is, it's pushing southeast, not at all to the northeast. So not conducive to swell production at all. A little bit of a cutoff low here. What's that, about 984, 986 millibars, something like that. Main fetch, aim south. Again, nothing of interest. It builds a little bit. Here we go. 35 knot winds on Monday night. More interest here. The far southeast Pacific, a broader area, 35 knot winds. Aim northeast. Still, neither of these are really in the swell window and not particularly impressive. High pressure, still in control. We'll just sort of roll this out. We get a little gale here. When's this? On Wednesday night. Yep, we know there's a little bit of trough forecast there. Tiny area, 45 knot winds on the edge of the Southern California swell window, and gone and out of the swell window in like 12 hours. So probably nothing would result from that. And then things really just continue to descend. A cutoff gale forecast east of New Zealand on Saturday night. We're almost a week out now. 45 knot winds. That looks somewhat hopeful, but seeing how it's 150 hours out, the odds of it actually developing are slim to none. Roll this out anyway, and it fades too. And there we are at 180 hours. So it's like, when is the southern hemi going to wake up? We've had, a couple of swells early in the year and a pretty decent one. What was that? Maybe 3 weeks ago, 4 weeks ago, and then just nothing since. Now, before we get into the current wave model, let's go back a week and just sort of see what's going on. You see, this was Sunday a week ago, an area 20, 22, 24, let's say maybe 25 foot seas. Yeah, 25.7. Pretty far to the north in the central South Pacific. Swell from this system was actually had a little bit higher seas. I think they're up to maybe 27 or 28 feet a day or so before this. This is Sunday a week ago. Swell from this is starting to hit California right now. And there's a nice little spike from this thing in Hawaii. I think maybe 3 feet at 15 seconds, pure swell, something like that. So there were some sets. And there is expected to be some surf into mainly Southern California by tomorrow, by Monday morning. Nothing huge, but some surf. Then we sort of went through last week, and we've got, again, this pattern of these troughs in the far southeast Pacific. Got a little bit of seas, nothing of too interest. But then on Wednesday night, we see this sort of blow up here, 28-foot seas in 2 pockets, then building to 32. It actually says 33 feet here. And the Southern California swell window ends right here. The Northern California swell window, this is right on it. So at least it's in the window. But the cool thing about this, look at this. We'll just go back, sort of watch this. Bump, bump, 32-foot seas, and then fading. It's going basically, how far? North, maybe, 400 miles or so, maybe 500 miles. And pure north, that will push some swell. Swell is in the water. This was as of, Thursday, midday, and it faded out, and that was the end of that. And that gets us to about to where we are today. But the point being, swell, when you get a storm that has some decent seas, that is pushing due north, or basically at the target, in this case the target would be California, then you can actually get some decent swell. And so there is some swell in the water. All the doom and gloom we were sort of talking about earlier, don't necessarily take that completely to heart, because there is swell in the water. It'll arrive later in this week. And, might be some, especially Southern California, it sort of catches these real south angle swells pretty well. So there could be some decent size later in the work week into the early part of the weekend. So a little bit of something to ride. But, after that, that's it. So get what you can. And so for the sake of it, we will go through this week's wave model. We know, okay, what do we got? 20, 22, 24-foot seas, and that's really nothing and pretty much outside the swell window. Nothing's going to result from that. Another one of these systems, here we go. We'll look at it here. Swell windows like right along in there for Southern California. Probably not a whole lot from that either. We're just looking for anything. And then this little cutoff low, remember that was on a Saturday night. Tiny area, 30 or 31-foot seas in the Hawaii swell window. So they could get a little something from this. But generally, you look at this, and it's just nothing really stands out. The other part is, notice the ice line here. 65 up to, 61 south, up to 60 south. So, we're at the peak of winter in the southern hemisphere. Ice is fully encased the South Pacific. That really cuts down the area where storms can form. They have to form in the upper latitudes here. You can't get any swell generated if wind's blowing over ice. It doesn't work very well. So really, we're kind of like at the transition here, hoping the North Pacific will wake up. We're not quite in the season yet, but let's go take a quick look. So we start looking at the jet stream about this time of year, looking to see if it'll get down somewhere around 40, get some 40 north, see if it'll get some velocity going to it. And then we're looking for a trough. In this case, the trough would be, pushing down this way, digging towards the equator. That would help form a counterclockwise flow. And of course, in the northern hemisphere, counterclockwise flow is the symbol or the symptoms of low pressure. And of course, you know the drill here, so we won't even go through it. Anyway, watching the jet stream, not particularly strong. We really want to see 140 knot winds. And so what do we have? Our flow, just eyeballing the past 60 hours here, it's up around 47 and very weak. 47 north, not doing a whole lot. So theoretically, now here we go, as we get into Friday, a trough, what is that, 120 knot winds is supposed to develop in the Gulf of Alaska. Not a lot of velocity, but, you know, there's actually one of these, I think, that just recently formed, like in the past 24 hours, a little bit more over this way. And here we got another one come a week out Saturday. Not particularly strong, but, you know, giving us maybe some hope. What we want to see is the active phase of the MJO wake up in a big way. That'll create westerly anomalies down in this area. And that's what really feeds the jet stream. But we're not seeing that quite yet. But we have some hope here. We think the atmosphere is transitioning. I'll just do a real quick check here. Northern Hemisphere, North Pacific, significant wave height. So we have the remnants of Hector. It passed south of Hawaii, generated some swell for Hilo in that area. Pretty good. So actually some pretty decent size, but not so much anywhere else. And it's sort of a fish storm right now out in the open ocean. The system here also, again, that trough we were talking about that developed maybe a day or so ago, created a little bit of seas, 20 foot, maybe even a little bit higher, 24-foot seas, somewhere right in this area, aimed barely off to the east. It is possible we could see a little background swell into exposed breaks in North California, but nothing too much. And then we'll just go through the week and see things kind of quiet. Hector tries to make the turn. Here's our new trough developing here. Looks like wind swell also for California. We'll get into that in a minute. But we're just looking for something that looks like real seas somewhere in this area, and we're not there yet. Still too early in the season, and it would take, typically, we don't see any signs of swell, at least in California, from the northern hemi. The earliest would be about the 15th of August, and that would only be on a strong El Nino year when the jet stream's already pretty solid, pushing way to the south. We don't see that yet. We're still in a La Nina pattern atmospherically, trying to move toward, well, we're probably almost neutral, but I think there's hangovers of La Nina still in the upper atmosphere. We're trying to get to neutral. And from there, we're going to try to get somewhere a little bit more favorable than neutral. And then one final inspection here. Now we're looking for wind swell. High pressure, in control, 1036 millibars in the Gulf of Alaska. Okay? You would think that it would be ridging perhaps a little bit more to the east. But this time of year, these highs tend to not do that. And you get this just like what we have now. No surf, no nothing. Things just kind of go dead. We're in that transition where summer's still here, but not at its peak. We're kind of past the peak. Winter or fall isn't quite here yet, you know, and you're just in no man's land. There's not a whole lot going on. So, yeah, we have some fetch along the North California coast. 20-knot winds, not doing much for generating wind swell, and nothing relative to Hawaii. You need at least a good solid patch of 15-knot winds out of the east. We don't have that. So we'll just go through here. We're looking. Yeah, high pressure tries to ridge a bit east here. It's not ridging south very much on Monday, but still just not doing anything. No real winds. And look at it. Then it goes even calmer, almost dead slack along the California coast. Light trades relative to Hawaii as we get into Wednesday, Thursday, then Friday. Okay, then high pressure finally moves close. Remember, heat low inland. High pressure here as the isobars tighten up. That starts generating winds. That's called a gradient as the isobars tighten. 20-knot winds developing off of Cape Mendocino on Friday, building to 30, almost 35 knots. So this is certainly good for wind swell into central California as Saturday. Good solid gradient. Here we go. And local light winds, almost an eddy flow, probably south winds here. Also notice our something trying to be resembling low pressure out here. We'll keep an eye on that. No real trades relative to Hawaii in terms of wind swell production capability, but certainly wind swell by Saturday for North and Central California. And we move into Sunday, and that pretty much holds. Then it starts fading later Sunday, and that's pretty much the end of that. Still maybe some wind swell into Monday. So California has some hope later in the week. All right, so let's move on to something a little more interesting. What's going on long term with the MJO and with the El Nino Southern Oscillation? As usual, we're going to first start talking about the MJO. Madden-Julian oscillation, periodic oscillation, traverses the Pacific, so this is the West Pacific, or actually here we'll say West Pacific, East Pacific here. This is the equator, that's New Guinea there. So it's this oscillation that moves very slowly from the West Pacific to the East Pacific. When in the active phase, it actually helps support storm formation by reversing trades or at least slackening trades. That imparts energy to the jet stream, and then when the jet stream's strong, both the north and southern hemisphere, that in turn helps feed storm development. So right now we have, and this data is from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but it also we can use it for monitoring the MJO. This is 5-day average data, so it's not like real time, but it gives you a sense of what's going on. We see big arrows here from the east, of course meaning easterly trades over the East Pacific, the date line right there. But look at this. West winds, not anomalies, full-on west winds in the West Pacific. That's the classic sign of the active phase of the MJO. And that's what gives us a little hope that maybe, just maybe, something's going to go on and the jet stream might get energized a little bit and help kick up some swell generation somewhere. Looking at anomalies, differences from normal for this time of year, we see a slack, we're just looking at the arrows here, slack pattern in terms of winds. That means normal. Normal, these big arrows just mean normal easterly trades. But once you get to about a point south of Hawaii, somewhere here, look at this. West, 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 west. Broad area of westerly anomalies. It's actually out and out westerly winds in portions of this area. That's a clear sign of the active phase of the MJO, and that is what we want to see. What's been going on the past 5 days? So 850 millibar wind anomalies. So this is up about 4,700 feet in the air, but pretty good proxy for what's going on at the surface. We want to look in what we call the Kelvin wave generation area. So there's Australia, there's New Guinea there, there's South America, Mexico, you kind of get it. The equator runs right along here. So the Kelvin wave generation area from 170 west, 5 degrees north and south of the equator. You draw a little box in your mind over to about the far side of New Guinea, 135 east. Right in this area, when you get westerly anomalies in here, that not only is a good sign of the active phase of the MJO, but then that also helps create Kelvin waves if the winds are strong enough and they blow long enough. Okay, and Kelvin waves, I think we've discussed this before, but that's basically warm water that gets pushed under the equator, about 150 meters below the equator, traverses the entire width of the Pacific, then it'll bubble up over here by the Galapagos in Ecuador, and that is a sign. If you get a couple of Kelvin waves like that in a row, then that is what helps fuel El Nino. All right, so we're going back to August 6th. We're just looking, doing a quick inspection of this little area on each one of these. Look at this, and the oranges and the winds out of the west mean westerly anomalies. So maybe the start of the active phase of the MJO was the 7th of August. We're looking here, more westerly anomalies, and here we go. As of the 10th, broad area westerly anomalies. Certainly looks like the active phase of the MJO. And then what's the forecast going to be? All right, so this is a different kind of chart. Same deal, 850 millibar zonal wind anomalies up about 4,700 feet. But this is the whole planet on one chart, and you get some history here, past history of what's been going on. So the date line runs right down the middle of the chart. Kelvin wave generation area between these two tick marks, so you just sort of slide your eyeballs down here. If you see blue, that's easterly anomalies. That's the inactive phase of the MJO. But what really jumps out here, starting right about here, August 6th, look at this. Yellows and oranges, westerly anomalies, filling the Kelvin wave generation area and building. Right now, it looks like we're almost in like a mini westerly wind burst. That is good. That suggests the active phase of the MJO. And it's supposed to continue for about another 6 days or so, then fade, and then back to some form of weak easterly anomalies. So things are looking pretty positive right now. The thing is, the active phase of the MJO shouldn't last for, what is this, a week? No, a week and a half. Yeah, it should be a little bit longer than that, though, maybe 2 to 3 weeks. But we'll take whatever we can get, right? So let's look at some more models, see if we can find some signs of what's going on with the active phase of the MJO. Blues, this is outgoing long wave radiation. Different style chart, but gives you sort of the same kind of data. Blues mean less sunlight reflectivity off the ocean surface, means more clouds, and that means low pressure. The yellows and reds suggest more sunlight reflectivity, positive numbers here, meaning high pressure, no clouds, meaning the inactive phase of the MJO. So the active phase of the MJO, where's our Kelvin wave generation area? Right around in here. So yeah, we'll call the active phase of the MJO in control, though kind of a cloudless active phase. But it's supposed to fade out about 5 days from now. And then per the statistic model, some sort of weak inactive phase is maybe to work its way into the West Pacific. The dynamic model suggests, there you go, there's your active phase, it's gone. About a week from now, inactive phase building in the Kelvin wave generation area. So both models are in agreement about a week more of this, and that's what the GFS model said. We just looked at it earlier. Suggests the active phase is to be gone, and that's the end of our westerly wind burst. Phase diagram forecast, another way to sort of look at this whole thing. So assume you're looking down on the North Pole, and the active phase moves from west, from the Indian Ocean, to the maritime continent, over the West Pacific, under America, across the Atlantic, across North Africa, back to the Indian Ocean. So it goes this way. The inactive phase, assume it's on the exact opposite side as well. So the heavy dots where the active phase is, the further away from this circle is, the stronger it is. So a moderately strong active phase of the MJO in the Western Pacific right now, but the green line is the 2-week forecast, and it's basically supposed to collapse in the next 7 days and then just noodle around in undefined in its position, maybe somewhere over the maritime continent 2 weeks from now. That per the ECMF model, and the GEFS model basically saying the same thing. So we're in agreement. Whatever active phase we got, it's peaked out right now, and it's going to start fading. And so, again, all the models appear to be in consensus. CFS model, this one goes out at about a month. Right now, okay, same sort of chart. There's the date line, western edge of the Kelvin wave generation area, this tick mark. So between these two tick marks going forward in time, the reds suggest heavily westerly anomalies in control of the Kelvin wave generation area, maybe to last another 5 days. There's your little patch of easterly anomalies we saw in the other chart. That'll be short-lived, not even a week, maybe a couple days. But the good news is, look at this broad area of westerly anomalies redeveloping. And also, see this purple line here? The low-pass filter. This is the bias towards low pressure. When you see it show up right smack dab in the middle of the Pacific, right on the date line, in the middle of the Kelvin wave generation area, that's a sign of El Nino. Sorry, El Nino. When you see the opposite of this, that's the El Nino. Anyway, so why all the westerly anomalies? Well, it looks like El Nino's trying to get organized. 40-day upper level model, okay, where the greens are, that's areas favorable for precipitation. You see South America there, New Guinea there. There's your date line, your equator running right through here. So, active phase of the MJO slowly fading out, moving east and out of the picture by about the 5th of September. Here comes the inactive phase of the MJO, and it does its thing, tracking across the Central Pacific into Central America about the 20th of September. And then what comes behind it? Well, it's hard to say. It looks like a neutral pattern here, but let's go to the long-range CFS model. All right, so here we go. Now this one's in reverse. The past history is down here. The forecast is up here on the top of the chart. Our area between these two tick marks right here going up through. Okay, and what do we have? Look at that. Westerly wind burst, it looks like. The yellows and oranges, strong westerly winds in the Kelvin wave generation area right now. They're supposed to back off. But look at this. They're not supposed to die completely. They're supposed to start building and building and remain solid as we get into November. So that looks very favorable. In fact, we're not seeing any easterly anomalies other than maybe a little tiny finger here for a couple days coming up about, 4 or 5 days from now, week from now, something like that. This is looking very, very favorable for this fall. So let's overlay the MJO. And as expected, the solid contour is the active phase of the MJO, right smack dab over the Kelvin wave generation area right now, but it's supposed to fade out. Then you get this weak, the dotted contour is the inactive phase of the MJO, but still westerly anomalies in the Kelvin wave generation area, just very light. And then as we move towards beyond that, active phase of the MJO with westerly anomalies, kind of a weak active phase of the MJO, but there's a reason for that. When you get El Nino building, the MJO kind of just fades away, but what you get is what appears to be a steady state active phase of the MJO, and it kind of pulses. When you get the active phase, it pulses more, but when it turns inactive, it doesn't disappear at all. And this sort of smells like that. Let's overlay the low-pass filter. And here we go. Now, this is interesting. So we see 1, 2, 3 contours of the area favorable for low pressure development, and holding steady through at least the end of this model run, 3 months out. It was interesting. We looked at the model yesterday, day before, something like that. It actually had 4 contours here. It's going to be interesting to see if whether it teases like that and kind of pops up and disappears every day. You know, this updates, and so see what happens. But seeing that tease kind of gave us some hope yesterday. We don't see it today. Maybe it'll come back. The other part here is this is the last dying remnants of La Nina, this dotted contour, the bias towards high pressure. It's smack dab over California right now, and even that is supposed to be gone September 21st. So when we say La Nina, so there's this discussion around El Nino getting coupled with the atmosphere and the ocean and everything sort of getting in sync. We still see remnants of La Nina, El Nino trying to build. You know, there's kind of this yin-yang dynamic going on. You know, El Nino gets a little bit of a hold, but then it backs off. So it's probably not till we get into sometime in the September time frame that maybe El Nino would be coupled. We thought it might be as early as August 8th, and then we started saying our written forecast maybe later in August. Now I'm thinking maybe even more like later in September. But the good news is we're not anywhere near any kind of La Nina, and the more we get into fall, the more that's going to favor El Nino development, the demise of La Nina. So we're moving in the right direction. It's just slow, and it's not super aggressive. All right, so much for the MJO. Let's start talking about what's going on in the ocean. Subsurface ocean temperatures. West Pacific here, East Pacific here. This is from the TAO buoy array. These are the anchor lines on the buoys, and the little X's are the sensors, the active sensors on the anchor lines. So, and from that data, you can kind of model it and get a sense of what's the profile. Warm water here, Celsius, 30 degrees Celsius in the far West Pacific. 28-degree isotherm. It was the whole way over to 142 or something like that. It is retracted. Why is it retracted? Because we had a big Kelvin wave that pushed this way, warm water, and that dragged the isotherm line this way. But now that Kelvin wave is fading. The 24-degree isotherm line, still 100 meters deep at 140, but it was actually fully pushing into Ecuador. It has backtracked significantly now. This is all pretty normal as Kelvin waves move east and then they erupt. All right? Anomalies, differences from normal for this time of year. So it looks like we're into the upwelling phase of the Kelvin wave cycle. So you see this right here, bubble of warm water. We'll get into that in a minute, but there was one of those, a very large one right here, associated with a Kelvin wave that was generated from westerly wind burst in February. Westerly winds in the far West Pacific created warm water, downwelled it, pushed it down, and then it took 3-4 months to make it the whole way across the Pacific. It erupted over here off of Ecuador, creating patches of warm water on the ocean surface, and that's sort of the start of how you get El Nino going, but you need multiples of those. In between Kelvin waves, you get kind of a cool burst for a little bit. Now, the interesting thing that's going on here is about 2 weeks ago, this wasn't here, and now all of a sudden we see warm water developing again, almost to 3 degrees above normal, suggesting that there was a westerly wind burst or a push of westerly winds in the far West Pacific. Actually, it was further west than that. It was over the maritime continent. We'll get into that in a minute. But it looks like Kelvin wave number 2 is trying to develop in the West Pacific. This is good. You need a series of Kelvin waves. Now, remember, it's going to take 3 months to make its way across here. So if this is August, so September, October, November, early December timeframe, not a huge Kelvin wave, but something. Okay, and of course, you can't have El Nino unless you have warm water here off of South America. So the more Kelvin waves, the merrier. Another version of that same data modeled differently shows 1, 2, 3. What's that? 1, 2, 3. Yeah, so a broad area of 2.5 degree centigrade anomalies here in the far west Pacific. Here's the last little remnants of Kelvin wave number 1 fading out. Here's our upwelling phase of the Kelvin wave activity. So notice the data, the depictation's a little bit different than what the other model said, but it's using the same raw data, sort of guessing at what's going on here. But large Kelvin wave, and if you saw the animation of this, okay, so we'll just sort of get this loop going. So where are we? Here we go. So watching this area, you'll see warm water starting to build right over in here, and there's the beginning of our Kelvin wave. This is just a, what is it, 2-month loop, something like that. There we go. So what does all this mean? Let's take a look for a second. So just real quickly, okay, typically we've thought, so here's New Guinea, right? Here's the equator. Dateline is way over here. Kelvin wave generation area is in this area over to, where we say, about somewhere right around, oh, there's 130, so 135. So somewhere right around in here, right? And we've always said if you get westerly anomalies in here, that takes warm water that's in the West Pacific, pushes it to depth. But we're going to modify that a little bit, because if you go over here, we started doing some inspection, looking. So we're over the maritime continent here, right? You go, well, what's going on here? And you start seeing, hey, look at this. There's like a channel running through here. There's a channel running up that way. There's channels coming through here. You start zooming in. Whoops, here we go. You start looking at all this, and let's see. You probably can't see it real well. Here, maybe we can slide this up a little bit so you can see the lower half. And depth right down in here. Watch that. So as I bring the mouse over here, you can see what's the depth in here? 3,000 feet. 3,000 feet in here, not particularly deep, right over in here. So you get, here's the equator. You got this long stretch, it goes 10,000 feet there, starts getting shallow, 7,000 feet. You get in here, and we're only, what are we, 1-2 degrees off the equator either way. So you got this broad area of relatively shallow water that sits there and bakes. It's got islands all around it, breaking up any swell from developing. And what this means is when the active phase of the MJO moves over this portion of the ocean, it's not so deep. Westerly anomalies get developing. You've got a broad pool of warm water here, and there's actually channel for it to start spilling over into the, you got it, into the Pacific. And what's over here? What's the depth here? 13,000 feet. 14,000 feet. Just scanning, 14,000 and, 12 or so in here. So what that means is warm water can be pushing from here with the active phase of the MJO and continue pushing off north of New Guinea. There we go, we'll back off. And then can start really falling to depth out in here. Here's your 13, 14, 17,000 feet. Deep in this region. There's the date line right there, and we're just still looking. What's this? How deep is this? 17,000 feet deep here. So this thought is just thinking that active phases of the MJO over the maritime continent with warm water present actually start spilling warm water from this area into the West Pacific, joining it with existing warm water that's already here. And then that, once it gets just a little bit past New Guinea, that's where your Kelvin wave starts forming as you get in really deep water out in here, and then you're good to go. So you get a push from, actually, let's do this. Here's a little, let's see if we can get our pointer here. Here we go. Line. We'll just draw a line from there, and this is just kind of a joke, but we'll do it anyway from here. That's 3,400 nautical miles from here to here of westerly anomalies. Remember, sort of as the Kelvin wave, as the active phase of the MJO slowly eases its way off to the east, picking up warm water here, pushing it here, all this area. That's a good broad area before it even gets to the date line to sort of get some momentum going. So when it finally hits here, it falls to depth, and your Kelvin wave is well formed. And anyway, that's what we think has been happening. Why and how this developed. Even though there seemingly weren't a whole lot of west winds in the West Pacific, it was really westerly winds over the maritime continent that generated this Kelvin wave. And it's on its way. 3 months, doesn't have a lot of momentum behind it, but it is a Kelvin wave, and we'll take whatever we can get. Okay, quick look. Upper ocean heat anomalies, upper 300 meters of the ocean. We're going back to December. Westerly anomalies, warm water, tiny Kelvin wave. This is January of this year. Didn't even make it across the Pacific. Upwelling phase of the Kelvin wave cycle, cool water. Our massive Kelvin wave developed from a broad area of westerly anomalies in the West Pacific and presumably over the maritime continent too. Generated a broad Kelvin wave. Here's a little bit maybe upwelling phase of the Kelvin wave cycle, and here's Kelvin, we'll call it really Kelvin wave number 2. This is Kelvin wave number 1. This Kelvin wave didn't even count. So this is Kelvin wave number 2, we think, trying to develop now in August, and off to the races, moving off to the east as well. And from here, we'll pick up the pace a little bit. All right, so what's going on? Last little remnants of Kelvin wave number 1 erupting off of Ecuador, the Galapagos Islands here. Yeah, scattered warm anomalies, nothing huge, nothing super impressive, but certainly not cold. Clearly a sign that La Nina is dead. Clearly not a sign, though, that El Nino is developing in any significant magnitude. But the main El Nino monitoring region doesn't even start to get to 120 west. From, 5 south to 5 north and out to about 170. So draw a box here and you go, yep, by and large, temperatures are warm, slightly warmer than normal. The trend, this is a sea surface temperature trend, cooling, right, in little pockets. Why not? Why is that happening? Well, for one, there's been easterly anomalies here. Look at that, cooling right off of Mexico, related to, what was that? Hurricane John. That hurricanes cause upwelling, a lot of wind. Anyway, so cooling because the Kelvin wave has pretty much done its thing, so there's not any more warm water to erupt to the surface. So, of course, temperatures are going to cool. But off of Chile and Peru, pretty much normal trend. And out here in the main El Nino monitoring region, pretty much normal. Not cooling, though. The overview trend, yeah, pockets of warming. So here's the Nino 1.2 region here. Yeah, it's always kind of cooler along Peru and Chile. No real signs of any strong El Nino or anything going on there. Sort of this generic warming trend, though, over the entirety of the equator, main El Nino monitoring region, right in this. Let's take a look at actual temperatures. Here we go. Here's the trend for Nino region 1.2. That's like Chile and Peru area. A little bit below normal, half a degree below normal, 0.556. And that's about what the chart shows. But in the Nino 3.4 region, we're positive 0.18. El Nino doesn't even start till you're at 0.5. We have yet to reach that at any point so far this year. You know, we were up to, about 0.49 or something like that, but then things have dropped off. So our Kelvin wave is not particularly impressive. It's pretty much done its thing. So if anything, temperatures will drift down some, at least according to this. So what's the effect on the atmosphere? We've had warming. It's not great warming, but it's not cooling either. What's going on in the atmosphere? So we look at the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. Negative numbers over a long period of time suggests, moderate period of time suggests the active phase of the MJO. Over a long period of time suggests El Nino. All right, index today, minus 21.55. Yesterday it was down minus 30, minus 31. This is kind of a, look at this, a bit of a trend here. Not a huge trend, a 12-day trend of negative, getting more negative. That's certainly a sign of the active phase of the MJO. What's going on with the 30-day average? Strips some of the noise out of this, and it's trending negative now, minus 2.30. Nothing earth-shattering. If it was down around 15 or 20, then we'd be going, this is interesting. Right now, still basically bouncing around neutral. The 90-day average, though, that takes even more of the noise out of this. We were at minus 2.51. If it was down around minus 8 or 9 or 10, then we go, that's El Nino. Kind of backed off. But now it's heading back down, minus 1.89. So all this is, at this point in time, just suggesting a neutral pattern, right? We're still trying to get rid of La Nina, the hangover from La Nina. It's still in the atmosphere, and it just won't let go. But we're certainly, at this point in time, it says we're not in La Nina anymore. We're in a neutral pattern. And the hope is that we're moving into something warmer than neutral. And then the other thing we look at is the ESPI. Instead of measuring the difference between pressure between north of Darwin, Australia, and Tahiti, it's rainfall. Maybe a better way of measuring. So the really good news here, take a look at the index, minus 0.01. So what's that mean? We're 1/100th of of a deviation away from normal, effectively saying we're neutral. This is the highest this index has been. We want to see it be positive. We're like one hair away from being positive. Probably by tomorrow we'll be there. The point being, if this goes positive, or even sits here at 0 for a couple of weeks, then we can officially declare La Nina dead in the atmosphere, right? Then it's all gravy after that. Then we're moving towards El Nino. You got to get rid of La Nina in the atmosphere first, and we're happy to report that this index, which has just been stubborn as can be for months now, is finally effectively neutral. When we look here, we're looking for some signs of precipitation over in this area that's above neutral. We don't see it. We just see kind of a neutral thing. So the index is probably pretty spot on. And then finally, the forecast for the Nino 3.4 region, sea surface temperatures. Now this is interesting. This model had been saying these temperatures would be going up all the way through July, August. It continues stubbornly to suggest a steep upward trend. We don't see it, though. There's no Kelvin wave coming, so how are you going to get temperatures to all of a sudden go from, let's say, early August at 0.25 degrees above normal up to 1.65 above normal by November 1? I don't know. We'll see. The model's very optimistic here, we suspect. But still, if anything, it's pushed even more optimistic. I think the last time we did this 2 weeks ago was down about 1.4, so it's actually nudged upwards. So hard to say. Maybe the model just doesn't have a clue what's going on, or maybe it sees something we don't. Hard to tell. But the other models, let's think the update is not till we get into September. All the other models are saying some sort of a weak to moderate El Nino developing as well. So I guess we'll see. Maybe what's going to happen is we'll have a teaser El Nino. That is, not really much of an El Nino this year, but maybe it'll hang on for next year. It's kind of early. I mean, we just are recovering from La Nina, and that was barely a weak La Nina after 2 years of what was considered a super El Nino, though it probably wasn't really a super El Nino. It was just a good solid El Nino, but statistically it was. Anyway, so the models are still optimistic. Anyway, let's put a bow on this. So, small southern hemiswell starting to hit Southern California, working its way up into Northern California. Nothing solid in size, but maybe a stronger one as we get later in the week. A little bit of wind swell in the mix as well. After that, really nothing is suggested from the Southern Hemisphere for the next week. And remember, if you don't see anything on the charts for a week, it takes another week for it to migrate up into Hawaii and California. So basically, after these swells, probably 2 weeks of nothingness going on. Watching the Northern Hemisphere, hoping for something. Not quite there yet. The jet stream doesn't quite have enough energy. But the active phase, the MJO, is in control, at least for the moment. Supposed to go inactive. Hard to say. Probably not a whole lot going to happen immediately. We're still sort of in this doldrum in between, La Nina and El Nino trying to fight it out. We'll see what happens. Very much drama, right? Not a whole lot, honestly, but we'll see. There is hope, at least, and I'll take hope over La Nina any day of the week. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.